Hi, everyone, and welcome to Path Models and Mediation Part 2. We are going to pick up right where we left off. So, we finished kind of talking about the different types of bootstrap confidence intervals and the different things we can ask for, like standardized coefficients and R squared. Real quickly, I want to talk about the just identified model, or the model in this case where we included the direct effect, the relationship between X and Y in the model, and basically illustrate some of the different things that we might want to define because we're interested in them and also might want to report them. So I'll run this quick and then talk about it. So you'll see A and B, that part is the same. And now I'm adding C. Technically it'd be C prime in classic mediation terminology. Indirect effect part is the same. But now I'm defining the total. This is the total effect. So the direct effect, or C prime, plus the indirect effect. Then I'm looking at the proportion. So out of the total effect, how much of that does the indirect effect account for? So that's all the things I want. Then I'm going to actually fit this model to the data, doing bootstrapping again for 1000 to hopefully not take too long. Whether it's bootstrapping or some other technique, it does offer the benefit of forcing you to take breaks sometimes. So get a sip of water or run to the bathroom. Okay. Now let's look at this. So again, differences. Now we have the C path in there. And then we added these things down here as well. So notably, that indirect effect accounts for a large amount of the total effect, almost half. Okay, moving to this next part here, we're going to introduce another mediating variable. You may have forgotten that we had an M2 when we first opened the data set and looked at it. And we're going to use this to illustrate several things. First, on a more fundamental level, we're adding another mediator, but in principle, adding another variable means we're going to have more degrees of freedom. Or in principle, there's more ways that we could set our model up and specify relationships among our variables. This can make it more likely that you end up with an over-identified model, which I had mentioned in terms of testing. So what we'll talk about here, we'll actually estimate multiple models, and then we can actually test them against each other. So first, again, we're going to treat this as another mediator, but in principle, it could be anything else. But just to illustrate what you could do and the types of indirect effects you might want to look at when you have multiple mediators. So the first one we're going to start out with is called parallel mediation. So that's what we have here. We have the first mediator regressed on X, second mediator regressed on X, and then we have the dependent variable regressed onto both of the mediators. You'll see I just still be using A and B. I've just added numbers now in terms of the labels. And because we have two mediators, we have two indirect effects that we're looking at here. Again, following the same steps, first ran that and then fit the model. Okay. Oh no, I just ran it again. Okay. Let's look at a summary. So now again, we see we have two indirect effects. We get bootstrap standard errors, and we can do what we did before. Again, in this case, I'm asking for bias corrected confidence intervals. And in this case, we're going to have two indirect effects, but otherwise, all the same things. Quick thing to know about that previous model. So we excluded some things that we could have included. So we excluded the relationship or potential relationship between X and Y, a direct effect. And in this case, too, we also could have included, or it would be common to include a covariance or correlation between those mediators. So if we scroll up here, just to illustrate, well, you see we have 2 degrees of freedom. So it technically wouldn't have those 2 specific paths I just mentioned, but in this case, we're excluding 2 possible relationships that we might or might be common to include. So we have 2 degrees of freedom. So we can add different things. Just starting as one basic point here, let's add in that covariance between the mediators. Running through the same steps. And notably here, you'll see I did 2 tildes. That specifies a correlation or a covariance between variables. Okay, now let's look at it. Notably, one thing, it's still significant, but notably when we excluded it before, for comparison, the chi-square was much larger. Likelihood ratio tests generally want smaller. It's going to be indicative of a better fit, usually. So that's one thing to note. Again, we have our indirect effects here. And then we can get, again, I'm using bias corrected there. And I forgot to mention there is that covariance. In this case, it is a covariance because we can ask for standardized and then get that correlation. But now here we get to what I think is kind of the interesting part and broadly applicable to a broad array of statistical techniques beyond just path models. So now we had these 2 models, right, which were the same, the 2 mediators, and one we excluded the covariance and one we included. This is an example of what we'd call nested models. So we can actually directly test them against each other to determine which one essentially is better. Are they different? The null hypothesis in this case is that they are the same in terms of providing an equal fit to the data. And in this case, it's actually a really simple test. It's just the difference in chi-square values. Again, the chi-square values come from a difference in likelihoods, one likelihood representing the sampler or observed data, and one likelihood model implied data. So that original chi-square is capturing that. So each model has one of those, and we're just looking at the difference between them. And that's how we actually quantify, in this case, that test, a chi-square difference test. So it's really simple. Again, I'll show you the formal test here, but illustrating the kind of basic things that you can do. We could just do this, ourselves here. The degrees of freedom are just subtracted, and then the test statistic, a difference in chi-squared, is chi-squared distributed. So this is relatively easy to figure out yourself if it's statistically significant, but I'm also going to show down here how you can do that. There are a range of different tests you could do using this one. Right here, this is specific for Lavaan. So we're doing this type chi-square right here. So putting both models, and then it's going to show us that. So the difference in chi-square, we have 1 degree of freedom. So covariance in there versus covariance not being in there. And in this case, it is statistically significant. So including that covariance, at least statistically, that would be a better fit relative to excluding it. So that was an example of parallel mediation with multiple mediators. Another thing that you could examine would be serial mediation. For example, X predicts M1, M1 predicts M2, and then M2 predicts Y, or the dependent variable. You can play out with a bunch of different things, especially in terms of practice. You probably wouldn't want to do that. You'd want to think about it kind of theoretically and based on prior literature for a big important research project. But in terms of practice, I think it can be pretty fun to try out some different models. So in this case, you could actually do that. You could try out a serial mediation model and test it, for example, against the models that we just did here, the parallel mediation model. But this was a basic introduction. I have some additional notes down here, like the assumptions of maximum likelihood that we used in this case. A note, as I mentioned before, we use maximum likelihood, but you could use ordinary least squares estimation if you were going to test mediation. I also have this note. Andrew Hayes created the process, which I think is actually available for R, but it's available for a lot of things. And that can be a nice way for both moderation and mediation. Actually, a relatively straightforward way to do it. But I like this path model way, and it's going to be more, I think, kind of general use to you for other types of modeling techniques. But that's definitely a resource that you might consider and look at. It basically, quickly does what I just showed you here in terms of the bootstrapping. Last couple notes, you explore further things like moderated mediation. You can check that out, explore definitely more complicated models. This was a simple introduction. Last thing to note that I kind of didn't mention before, but want to mention, by default, no intercepts are included, so you actually have to ask for them. You say mean structure equals true. So you just add that specifically in the SEM one. I gave the example down here. So you can have the intercepts, but by default, they are not reported. Well, all right. Thank you for watching. I hope this was useful to you. And I'll have another next video in the series coming out soon. Thank you for watching.